Hey folks, this is Praveen and today we're gonna solve the another lead code problem, uh, permutations. The problem statement says given an array num of distinct integer, written all the possible permutation, you can return the answer in any order. So basically they will get the array of integer which would be distinct, and we'll have to generate all the possible permutation of it. So in this example we can see 1 2 3 3 1 2 3 1 3 2 2 1 3 2 3 1 3 1 2 3 2 1 are the permutation of 1 2 3, and similar to that we have got the input 0 and 1. So the possible permutation would be 0 1 and 1 0, and if we get only one element, then one integer element, then we'll be having only one permutation of it. So how we're gonna solve this problem? So to explain that, let's go through this integer array 1 2 and 3. So at this point of time we are having three options, whether we can take 1 2 or 3 on the first position. So let's assume we are considering 1 on the first position. So now we can put 1 on a temporary array, and now we'll be remaining with the 2 and 3. Now here we are having two options, whether we can pick 2 or we can pick 3. So initially we can pick 2. So now we'll be having 1 and 2 in our temporary answer, and we'll be remaining with 3. So now we are only remain with one option, that is 3. So now our like one permutation would be 1 2 3, because we are not remaining with any further element. Now we'll backtrack from here, we'll go up. Since we already consider 3, we'll go further up. So earlier at this position we considered 2, so now we'll consider 3 on the second position. So now we'll be having 1 3 in our temporary answer, and we'll be remaining with 2. So we have here only one option, that is we can pick 2. So our another permutation would be 1 3 2. Now again we'll further backtrack here. Since we already consider 2, we further backtrack here. We have generated the permutation for this set, so we'll backtrack to the root position. Now here earlier we took 1, now we'll consider 2 on the first position. Now we'll be having 1 and 3 in the remaining. So either we can pick 1 or we can pick 3. So let's assume I'm picking 1 here. So now we have 2 and 1 on our temp result, and we are remaining with 3. Now since we had only one option, so we'll pick 3. So 2 1 3 is our another permutation. Now we'll backtrack from here. So earlier we considered 3 here, so we'll further backtrack here. So we already considered 2 and 1 on the second location. Now we'll consider 3. So now our combination would be 2 3, and we are remaining with 1. So our final permutation would be 2 3 1. Now we'll backtrack here. We already consider all the option. Further we'll backtrack here. We again consider all the option. We'll come on the root. Now we'll take 3 on the first position, and we'll be having 1 and 2 for the second position. So we'll first consider 1. So we'll be having 3 and 1 in our temp answer, and we'll be having 2 with remaining. Now we'll choose 2 in our answer, so we'll get another permutation, that is 3 1 2. We'll further backtrack here, then backtrack here, and we'll be getting 3 and 2 on the second position, and we'll be remaining with 1, and we'll be getting another permutation which is 3 2 1. Now we'll backtrack here, and on the root node. Since we already consider 1 2 3, so that is what is our like whatever the permutation we have got on our leaf, that would be our answer. So let's write the code for this. We have got the permute function here. I'll write another helper function here, like let's call it private void backtrack. This would be having input as like list of integer. So this will basically gonna hold our result, so I'll call it result. Then we'll be having list of integer to hold the temporary result. Integer to hold the temp result, I'll call it temp. And we'll be having one int array which will keep the remaining. So this is what the input argument will be having in our function. Now our base condition would be when the remaining dot length, when this length will become 0, means we don't have anything in the remainder. So what we're gonna do, we're gonna add temp to the result, and we'll have to write the new array list, otherwise it will pass the reference. So here do new array list and pass temp here. So in this way, when we don't have anything in the remainder, at that point of time we're gonna add like temp in the result. Now if we have something in the remainder, what we're gonna do here, we're gonna iterate over the remainder list. So we'll start with I equal to 0, I is less than remaining dot length and I plus plus. Now here first we'll add this to our temp result, like the element at the ith location in the remaining, let's put it in the temp result. Now again we'll call the backtrack function here after taking the result. So we'll pass the result as it is, then we have added the current element. So let me do one thing here, let's call it int, since we pick the item, right? What we pick element at ith location, so we call it pick, and thus at pick here, and now we'll have to pass the remainder here. So we'll have to filter our this whatever the remaining we are having, from that we'll have to remove the pick, right? So what I'm gonna do here, we can call arrays dot stream dot, I'm gonna create the stream of remaining, and we'll call the filter function here, and let's write the lambda for this, and value should not be equal to our pick, whatever element we have picked. So basically we are removing the one we have considered from our remainder, and we are again calling the backtrack function. And once we come out from this backtrack, we'll remove the last element whichever we have added to the temp from the temp list. Remove, then simple is remove dot length. I think it should be size. We'll see if we'll get the error, but I think it should be size. Yes. This way we're gonna add it to the temp list, right? And with like we'll call the backtrack function, it will call this, when it will come back we'll remove it from the text. So we'll first pick it, and later on we'll remove it when we'll do the backtracking. So after this, like once this complete function will run in our result, we should be having our answer. So what we can do, in our caller function we can create result to new array list, right? And we can call the backtrack here with result, we'll pass result here, we can pass the array list, simply type integer, and as a remaining, initially we'll be having complete num in the remaining because we are starting from here, and here we should be returning the result. So hopefully this code should work. Let's try to run this code. oh, oh, so I misspelled here. Further, okay, sorry about this. No, oh, the syntax is not correct. Arrays dot string dot remaining dot filter value not equal to pick cannot be converted to int array. So here I'll have to write dot to array. I think yep. So this is working. Let's try to submit this. Yeah. So yeah, that's how we can solve the permutation problem. And this is a like important concept of backtracking. So this we can use to solve multiple problems. So hope this this will help you to understand the permutation problem and the solution. If you like the video, please like and subscribe to the channel. Thank you.